In this problem, it says for the purposes of constructing modified box plots, outliers are defined as data values that are above Q3 by an amount greater than 1.5 times the interquartile range, or below Q1 by an amount greater than 1.5 times the interquartile range, where IQR is the interquartile range. Using this definition of outliers, find the probability that when a value is randomly selected from a normal distribution, it is an outlier. So I have a picture of a normal distribution here, and I'm going to mark on there where Q1 and Q3 are found. So we're going to say that Q1 is roughly here. Now that seems surprising that this would be 25%. And then this area is also 25%. But because of how the normal distribution rises so quickly in the middle, it actually does work out mathematically that way, even though it doesn't look like it makes sense. And then we have, so this is Q1, and then Q3 is about here, which means that this is also 25%, and this is 25%. So how do we calculate the values of Q1 and Q3 first of all? That's what we want to start with. We're going to work with the standard normal distribution because they didn't give us a mean and standard deviation. So we're going to say that the mean is 0 and the standard deviation is 1. So to calculate Q1, I'm going to say, well, I know that that's equal to the 25th percentile. So I can calculate this by using inverse norm, 0.25, mean is 0, standard deviation is 1. And honestly, you could use any mean and standard deviation that you wanted to in this problem, and you'll get the same result as long as you keep the mean and standard deviation the same. So here I'm getting, for a z-score, I'm getting negative 0.6745, and I'm going to round this to 4 places because in the problem here it says to round to 4 places, so I'll go with 4 places here. So that's how I knew that this Q1 was falling between 0 and negative 1. And then I can do the same thing for Q3. Honestly, I don't really need to. Q3 is going to be the 75th percentile. I can put this in the calculator. But it's just going to come up with positive 0.6745 because of that symmetry of the normal distribution. Okay, so now we have our 2 quartiles. I'm going to erase some of this just to, it's a little overwhelming, all that information there. Okay, so now we want to find the interquartile range. Well, that's just Q3 minus Q1. So I'll take 0.6745 minus a negative 0.6745. And I get 1.349. Okay. So now we want to find Q1 minus 1.5 times the interquartile range. And that is going to be negative 0.6745 minus 1.5 times that interquartile range, 1.349. And that gives me negative 2.698. Okay, so where is this on my distribution now? That's going to be roughly here. Negative 2.698. And so similarly, we can find our upper boundary by just making that a positive 2.698. Maybe I should move that over a little bit. But honestly, it's not terribly important where you draw the line specifically. So what we're trying to calculate is what is the probability of having a value that falls into one of the two tails. So there's a couple of ways to calculate this. I think the most direct way to do this is we want to find the probability that we have an outlier. And so what I'm going to do is rather than calculate those two small tails, I'm going to do 1 minus the probability that we have a value between negative 2.698 and positive 2.698 and subtract that from 1. And so I can do this by doing normal CDF, or 1 minus normal CDF. And my two boundaries are 2.698 and positive 2.698. And my mean is 0, standard deviation is 1. And I get 0.000, nope, just 2 zeros. That's what I did have. 0.069758542 is what I got. And then we want to round that to 4 decimal places. And so that's going to be 0.0070. And that's how you get that answer.